on the present value of an annuity. And so lesson 3 looked at the future value, so we're going to look at the present value today. And for the warm-up it says, Cash for Life is a lottery that pays people $1,000 a week for 20 years. That is, the person wins $1,000 per week for 52 weeks in a year, and really what they only pay you for is 20 years. And so in total, the person would have $1,040,000 that they actually earn over the span of the 20 years. However, if a person wishes to receive all of the money on the day they win the prize, they receive a much lesser amount, which is approximately about $700,000. Now, why does that happen? If the person won $1,000 a week for life, why wouldn't it make sense to just give them $1 million and $1,040,000 instead of giving them a much lesser amount? Well, the reason for that is because what actually happens is $700,000 represents the present value of the annuity, or the present value of the lottery. So right now the value of the lottery is $700,000. But if the person decides that, you know what, I'll just take $1,000 a week for life, what actually happens is the Cash for Life, or the company, the Ontario Gambling Company, they will give you $1,000 after 1 week, but they take the rest of the money, which is the $699,000, and they take that and they investment. And so they invest that. And so what happens is they actually earn interest on $699,000. Then the following week they give you more money, they give you another $1,000, and then the remaining $698,000 they earn interest on that. So what happens is over a span of 20 years, this $700,000 actually accumulates to a value of $1,040,000. So this is how much money you can actually get out of this $700,000. $700,000 represents the present value. $1,040,000 is actually the total of the withdrawals that actually end up being made. Okay? So why don't they give you that money? Well, this is actually the present value of the annuity. So $700,000 represents the present value of the annuity. Okay? And so if they pay the winner weekly, they earn interest on the remaining payment. So that's why they don't actually give you the $1 million, they actually give you a smaller amount. So if they pay the winner weekly, they earn interest on the remaining payments. So the rest of the money they keep earning interest on. Okay, so let's take a look at the definition of the present value of an annuity. And so it's the amount of money that must be invested today at a given interest rate and compounding period in order to make regular annuity payments. Or in other words, that means that you have the money right now, and so you need to make regular annuity payments or withdrawals so that this amount of money that you already have starts shrinking over time. Okay? So if you have a loan, then the present value is the amount you owe right now. So let's say, for example, you borrow money from a credit card, and so the amount of money you owe right now is the present value of the annuity. As you pay off the credit card, this amount, the present value of the annuity, shrinks over time because now you're paying towards it, and so the amount of money you owe starts decreasing and decreasing and decreasing and decreasing over time. Okay? So let's just summarize the two types of annuities that we looked at, yesterday's lesson and today's lesson. So just to summarize, we have the future value of an annuity and the present value of an annuity. In the future value of an annuity, the difference between these two is that in one of them you don't have the money and you're putting money towards an account so that you have money in the future. In the present value, you have the money and you're decreasing that lump sum that you have by either making withdrawals or payments towards it, so that eventually this lump sum that you have shrinks over time. Okay? So the regular withdrawals indicates that, let's say you won a lottery, and so let's say you have $100,000 there. The regular withdrawals would be like withdrawals of $1,000. And so what ends up happening is this lump sum amount that you have starts shrinking. Okay? In terms of a regular payment, that would be if you owe money, so if you have a loan of some sort, and then you start making payments towards that loan, and so the amount of money you owe starts to shrink over time as well. Okay? So, in future value of an annuity, you don't have the money right now, but you're making small payments so that you eventually have money in the future. Okay? So money is being put in so that you can save for the future, to get a car, go on vacation, go to university, etc. In present value of an annuity, you are making regular withdrawals or regular payments from a lump sum that you have right now. So you have the lump sum right now, you have it today, and so it's decreasing over time by your regular withdrawals or your payments. So money is being taken out. Some examples of these are loan payments, so paying off a loan, or lottery winnings, which means taking money from a lottery winning that you have. Note that annuities always have payments or withdrawals at regular intervals. That's something that you need to remember. Regular payments at regular intervals, or regular withdrawals at regular intervals. So here's the formula for the present value of an ordinary annuity. We're not going to derive it this time, but here it is. It's similar to the one that you had for future value. The only difference is, in the numerator, you don't have the same thing. For future value, we had 1 plus I to the exponent n minus 1. For present value, you have 1 minus 1 plus I to the exponent negative n. Okay, so it's a little bit different. You're going to be given these formulas on the test, so you don't have to worry about memorizing them. Just make sure you have them with you when you are doing your homework. PV represents the present value, so that's all PV represents. You can use the letter P if you want as well, but it just represents the present value of the annuity. R is the regular payments that you would be making. I is the interest rate per compounding period as a decimal, so we know that from compound interest and when we looked at future value of an annuity. N is the number of compounding periods. That's exactly the same as compound interest and future value of an annuity as well. And note that the compounding interval must be the same as the payment interval. So if interest is being compounded monthly, then your payments must be made monthly as well.